Here is another stoichiometry or extended mole train example on it's number 6 and page 7 of your homework packet. Here we go. So it says, what mass of nitrogen or N2 gas is consumed in the production of 240 grams of ammonia NH3? Well, the first thing I'm going to do is balance the equation. I got two nitrogens. So my guess is that I'm going to have to put a 2 right here to balance that out, assuming this is a 1. Okay, that gives me 6 hydrogens. So what times 2 equals 6? That's going to be a 3. All right. The next thing is, it says, what mass of nitrogen? So we don't know the N2. So I might just put this right here. I think I'm just going to draw this right up here, a little question mark, and it says mass. That's a question mark, and that's a grams. So that's going to be our ending point. I'm going to put a question mark right here. I always like to put what I don't know on top, and I'm going to call that N2. So that's our destination. Now, the other thing, I got to know where we're at. It looks like we have 240 grams of ammonia. So this is going to be our starting point. And ammonia is NH3. So I'll call this NH3 right here. And that's our starting point. So first thing, we balance the equation. And then we figure out what we know. And I might write this right above it. Sometimes I write it right below, but I'm going to run out of room here to do that. So I'm going to just get 240 point dot, and I'll put a G right there. So I know my product and I don't know my reactant. I know the NH3. It doesn't matter if it's a product reactant. What I know goes on the bottom. What I don't know goes on top. Can we figure out, if we know a product, can we figure out the amount of reactant? Yeah. If you're making sandwiches and you know how many grilled cheese sandwiches you want to make, then you can figure out how much bread or how much cheese that you need, whether in terms of slices or in grams. Same thing here. If we know how much we're going to produce here, we can figure out how much nitrogen we need. We could also figure out how much hydrogen we need, but we're concerned with the nitrogen in this problem. So we've balanced our equation. We figured out our starting point. We figured out our ending point. We got to plan our route. So there's no connection between grams and grams. I can't just look at this and say, oh, 2-to-1 ratio, 1 is half of 2. I can't just cut this in half and be done. Okay, I have to do more work than that, because this equation doesn't say 1 gram plus 3 grams forms 2 grams. It says 1 mole of N2 plus 3 moles of H2 forms 2 moles of NH3. So I got to convert to moles first, then go through my mole ratio, and then go back to grams of N2. Okay, because that's what balanced equations say. All right, so we've got our plan. We got, not only do we know our starting and ending point, we know that this is going to be our route. Now we just got to calculate the problem. So I write what I know to start out, and I might just do that right over here and say 240 point, and I'm going to say grams of NH3. All right, and probably could put a little space in there like that. Maybe I'll do that to save a little space. The reason I put a point there means it was 3 significant figures instead of 2. And we'll look at that when we get to our answer. Okay, the next thing is I'm going to do a times. Oops, I don't want to do the times right there. Maybe I'll come back down here, do it a little draw, and look at our next step. Okay, so it looks like I'm going to put a little line here. And let's see, we're going to go from grams to moles of NH3. So if we're coming from grams of NH3, I'm going to put that down here. And I'm going to moles of NH3. So I'm going to put where I come from goes on the bottom, and where I go to goes on top. Okay, and because I'm working with 2 different substances, I do put the substance there as well, because I'm going to transition at some point from the NH3 train to the N2 train. So what is it? Oh, here's the molar mass, 14 plus 3. Whoops, that's not right. It's supposed to be 7 grams. All right. Looks like a mass, gonna want to create mass confusion by doing the wrong molar mass. 14 plus 3 is 17. Is it 17 moles in a gram or 17 grams in a mole? It's 17 grams in 1 mole. So because it's below the line, you're going to do 240 divided by 17. We're going from grams to moles. You're going to divide by the molar mass of NH3. So now we're right here. 240 divided by 17. I don't know quite what that is, and that doesn't matter so much. The next thing is I'm going to go through a mole ratio. So I might just text this in, and let's take a look. I'm going to, where I know where I came from goes in the bottom. So moles of NH3 is going to go on the bottom, and moles of N2 is going to go on the top. Why? What? A couple of reasons. What's up here goes on the bottom, so moles of NH3 goes on the bottom, and moles of N2 goes on top. What I know goes on the bottom, where I'm going to goes on top. Where do I look when I go from moles to moles? Because that's what we're doing. I'll draw a little thing in here because this is our next step. I go through the balanced equation. So I look at my coefficients. This is in front of the N2. This is in front of the NH3. So the 2 goes with the NH3 down here, and the 1 goes with the N2 right there. So essentially, when I go from NH3 to N2, I multiply by 1/2. Okay, just like if you're making double-decker ice cream treats, when you go from what? You go from scoops to cones, you have half as many cones as you do scoops if you're making double-decker ice cream treats. Same thing here, 1-to-2 ratio. Okay, now we've done this and this. We're to moles of N2. Now we got to get to grams of N2. It looks like we're going to multiply by the molar mass of N2. So I'm going to put what I know on the bottom, which is moles of N2 this time. And then what's going to go on top is going to be my grams of N2. Right? And what is the molar mass of N2? Well, if N is 14, N2 would be double that, or 28. Is it 28 moles in a gram or grams in a mole? It is 28 grams in a mole. So I'm going to put the 28 on top and the 1 on the bottom. Okay, notice how whenever we do molar mass, it is always how many grams per 1 mole or how many grams per 1 mole. But when we do mole ratios, that number isn't always 1. It just depends on what's in the equation. So 240 divided by 17 divided by 2 times 28. And I think it comes out to, I'll just draw a little arrow up here because I'm running out of room. I believe we get, if we round it to 3 figures, I get 198 grams of N2. Let's think about this answer. Okay, if this is 240 grams, I know conservation of mass. I know that the nitrogen has to be less than this number right here because it's 198 grams plus whatever grams gives me 240 grams. In fact, if somebody said, how much hydrogen would I be consuming here? You wouldn't even have to do a mole train. You could say, oh, 198 plus, 42 equals 240. So there's a lot of ways you can interconnect these problems. And this seems like it's probably going to be 200 close. It's going to be less than 240, but it should be a lot more than the hydrogen because the nitrogen has a lot more of the mass. That makes this up. Okay, just going to go back and just show one other thing with this. So notice, and just a reminder of our steps. All right, we balanced the equation first. Then we figured out where we were starting and where we were going. Then we followed that path doing our calculation and came up with this answer right here. All right, so maybe I should just circle that right here. And then we went back and made sure our answer made sense. Okay, well, I'm guessing it's gonna be less than 240, but not super much less. And that seems to make sense. So just going back, and you see this on page 2 of your homework packet, you got a nice Moultrain. It kind of highlights these steps. It says balance your chemical equation, identify what you know, your starting point. I put that on the bottom. And I said what you're trying to find out, your ending point. We'll clear this out here. So identify your starting point, identify your ending point, use the Moultrain to make your calculations, and then make sure your answer makes sense. It's kind of the same thing over and over when you do these problems, and keep practicing at it, and as you ride that Moultrain. All right, good work. Let me know if you have questions. Thank you.